For centuries, humanity has gazed at the sky, seeking answers. We have built theories, written equations, and speculated about our role in the grand cosmic story. Yet, all of our foundational ideas, our understanding of physics, cosmology, space, and time, have recently been challenged to their core. The James Webb Space Telescope has uncovered something astonishing that shouldn't exist: galaxies that are too ancient, planets too massive, and structures that are far too perfect have emerged from the telescope's observations. Even more perplexing, a steady, rhythmic signal has been detected, one that doesn't fit into any known astrophysical model. This is no ordinary discovery. It's a confrontation between what we believed and what may actually be true. The James Webb Space Telescope could be delivering one of the most profound messages in human history, suggesting that everything we thought we knew about the universe might be fundamentally wrong. Through a series of deep-field observations, the James Webb Space Telescope has captured some of the most detailed images of the universe ever seen. However, these stunning visuals were not just beautiful. They also contained anomalies. In the galaxy cluster AEL 2744, researchers discovered perfectly aligned light points and symmetrical structures, forming patterns that defy the chaotic nature of galactic evolution. In the spiral galaxy NGC 1365, unusual gravitational patterns suggested behaviors that contradicted our most basic models of physics. As Webb continued to peer deeper into space, strange anomalies appeared in multiple images. The further the telescope looked, the more peculiar the universe seemed. Patterns were repeating across billions of light years, with structures exhibiting geometric precision in a universe that was supposed to be completely random. Initially, scientists dismissed this as coincidence, but the frequency, perfection, and consistency of these anomalies led to a growing suspicion. Perhaps we're not seeing randomness, but a form of order that we simply don't yet understand. One of the most extraordinary findings was the discovery of the exoplanet HIP 65426b. Located hundreds of light years away, this planet has 7 times the mass of Jupiter and orbits its star at 3 times the distance of Neptune. Its star is only about 15 million years old, a mere blink in cosmic time. By all known theories of planetary formation, this planet should not exist. There's no visible protostellar disk, no leftover material, and no gravitational mechanism to explain how such a massive world could form so quickly and so far from its star. Some researchers now speculate that this planet might not even belong to its current system. It could be a remnant of an earlier stellar cycle, a relic from a previous star system that has somehow been transplanted into this one. For now, no answers are forthcoming, only a mysterious hot planet glowing at over 1,000 degrees in a system that shouldn't have had enough time to build it. Among the most surreal discoveries was the image of an Einstein ring, a gravitational lens, caused by a massive galaxy bending the light from a galaxy behind it. However, the Einstein ring around galaxy J418 wasn't just any lens. It was nearly perfect, a full, uninterrupted circle of light with mathematical symmetry so precise that even the most experienced astrophysicists were left astounded. For such an image to exist, the alignment of the galaxies must be exact, down to fractions of a degree, across billions of light years. This is not merely rare, it's statistically improbable on a cosmic scale. While gravitational lensing is a known phenomenon, the level of perfection in this instance has raised more questions than answers. Could this be evidence of a deeper symmetry embedded in space-time itself, hinting that the universe is not as chaotic as we once assumed, but governed by a geometry we have yet to fully comprehend? Perhaps the most revolutionary finding was the discovery of massive, mature galaxies that appear to be forming just 180 million years after the Big Bang, an impossibility in the context of our current models. Galaxies of such size and complexity should not have had enough time to develop in such a short span of cosmic history. According to our understanding, these galaxies should still be in the process of formation, or at best, in a chaotic state. Yet what Webb observed were galaxies as large and as fully developed as our own Milky Way, stable and mature, contrary to everything we know about the universe's early stages. If these galaxies are indeed as old as the data suggests, it would mean that our entire understanding of the universe's origins is crumbling. The Big Bang, once considered the bedrock of modern cosmology, may no longer explain the universe's beginning. Some researchers now suggest that we may be looking at a universe that had a history long before the Big Bang. In one particularly baffling discovery, the James Webb Telescope detected a gravitational lens effect in a region of space that appeared empty. No stars, no galaxies, no black holes. Yet, light from distant galaxies was bending and distorting, as though something massive was hiding in that void. While dark matter is often credited with this phenomenon, the intensity and precision of the lensing challenge that explanation. The distortion is too localized and too strong, behaving more like an object with defined mass and symmetry than a cloud of invisible dark matter. Could this be a remnant of something ancient, perhaps an unknown structure or object that still exerts gravitational force? Among the telescope's more controversial findings is the discovery of a massive intergalactic filament, a stretch of galaxies and matter that forms a structure over 1 billion light-years long. Scientists have observed filaments before, part of what's called the cosmic web. But this particular filament is different. Its alignment, density, and repeating voids suggest a pattern that resembles a framework laid across the universe, almost as though it were engineered. While some scientists argue that the structure is the result of gravitational attraction over billions of years, the symmetry is hard to ignore. Could these galaxies, the dark matter, and even the redshift patterns, be part of an intentional design, a cosmic blueprint? The most chilling discovery came when Webb recorded a series of light pulses in a void sector, signals that were too regular to be random and too faint to come from any known star. These pulses didn't match the patterns of pulsars or quasars, and they repeated at exact intervals before vanishing entirely. At first, scientists thought it might be a processing error, but the data was consistent across independent systems. The signals seemed to originate from an empty region. No stars, no nebulae, no heat signatures, just steady, precisely timed flashes. Some researchers are now asking a terrifying question. What if this is a message, not meant to be received, but simply to be noticed? And if so, who or what was meant to see it? The James Webb Space Telescope was designed to peer into the past, to show us what the universe looked like billions of years ago. But in doing so, it may have revealed something much deeper, that we are not merely observers of the cosmos. We are part of a system far older, more deliberate, and more precise than we ever imagined. Galaxies that shouldn't exist, planets that defy the laws of physics, signals with no clear origin, and structures that seem to suggest intelligence. These aren't anomalies, they're data points, real, measurable, undeniable evidence that challenges everything we thought we knew. If the patterns are real, if the pulses are deliberate, if the universe itself has a memory, then we are left with a question that humanity has never had to face before. Are we alone in this universe, or have we always been part of something much greater?